Hello, so this is video number 2 on how to build these desktop Muon counters. So in the previous video I kind of went over the different versions of the detectors. We're going to be building the one that has the SD card and the coincidence connection. This video is going to be going about how to populate the main PCB, okay, and the SD card PCB. Let's start off by just quickly looking at the equipment that you'll need for this this project. So if we look over here, I have a couple pieces of equipment that I'm going to use. So I have some wire cutters. I have a number 0 Phillips screwdriver. I have some tweezers for mounting the 0805 components. We're going to use a multimeter for testing the high voltage going to the SIPM. Crescent wrench, this isn't particularly needed, and a scope probe. So the scope probe I'll use in the 4th video for actually testing the detector to show you the different the signals and how to troubleshoot the detector. We also have a 50 megahertz oscilloscope, and you can see I have a detector plugged in into channel 1 here, just through a BNC cable. Okay, and the count rate does look much higher than I was expecting. Normally the count rate is probably about 1.3 given this current detector design and amplification and stuff. And what you can see is that every time that the detector triggers, you can see the pulse basically coming in. So this is the raw pulse from the SIPM. So this BNC is connected directly to the anode of the SIPM. And I do know why the count rate is so high. It's because I have a box of radioactive stuff sitting right above it. So you can see it just goes crazy as we get it a bit closer. There's actually quite a few gammas in here, which is probably the main source. Yeah, it's a gamma source. And so that's basically what's actually bringing the count rate higher than I was expecting. Okay, so what else do we have? So over here, I also have a hot air gun. So this will be for improving the surface finish on the scintillator. I have a fine tip soldering iron. And then I have all my surface mount stuff over here. Basically all the components for the detector sitting over here. Let's quickly look here. So you can see we have stuff related to the box. So these are the face plates. These are laser cut 2.5 millimeter acrylic. They're actually I actually have them manufactured at the same place I get my PCBs done. Here are the faceplate, or sorry, the aluminum enclosure components, and you can see the rails that the PCB sits on. Here is the PCBs. So these actually come manufactured together. They look like they come in a. So here I ordered a box of 25. They sent me 26. But you can see you just basically break off the piece that you need. So here's one that arrived, and they just crack off like this, and then you can clean off the tabs here if you want to. Sorry, not if you want to. You should clean those off. Okay. What else we have? This is optical gel. So this is for interfacing the scintillator and the SIPM. Here are the larger components for the surface mount main PCB. Here's the SIPM. Let's see if I can show that with my camera. So the SIPM is 7 millimeters by 7 millimeters. That's what it measures. The actual photoactive area is only 6 millimeters by 6 millimeters. Here's my scintillator and my reflective foil. So reflective foil, this is just normal household tin foil that I'm going to use. Okay. Besides this, I guess the other main thing that you obviously need are all the resistors and capacitors. And so I have a box here that contains all my surface mount resistors, capacitors, diodes, ICs, stuff like that. And then I have a reference list. So my reference list will tell me exactly what each of these components is. So let's say R4 here. Go to the list and it says R4 is 1K. Okay. A 1K resistor, 0805. Okay. So the reference list is available on the GitHub account. The version that we're building here is called the CosmicWatch Desktop Muon Counter with SD card. And what I'm going to do in this video is I'm just going to populate the resistors on one side. And I'll fast forward through that because that's not too interesting. And then I'll slow it down and we'll talk about the individual components on the back side. you can see that all my components, there's a silk screen basically that outlines which components fit where. So for example, you can see here, this here is the temperature sensor, and it kind of shows you the direction, and it shows you that the temperature sensor is supposed to be on this side of the board. Same with the reset button and the coincidence connection. Here is the Arduino. And then on the back side, these are basically where we do all the signal processing. Except for we also have the OLED screen header, which fits here. And then we also, the SD card actually fits on this side as well. The SD card PCB fits over there. Okay, so let's start off. I'm going to do this in multiple steps. I'm just going to stop the video and save it, make sure that it worked, and then come back on and populate this board here. I'll fast forward. I'll go quickly through how to do the resistors and capacitors. I think if you don't know how to populate these boards, you can just look up a YouTube video online. But I'll go slower through the actual main components afterwards. So let's start off by doing some of the components here. So the way that I'm going to do this is I'll actually just fast forward through this entire thing, and you can just watch me do it. Okay. So I have all the resistors and capacitors on. Those are the easy ones. Let me just quickly talk about the different components of the circuit. So you can see here on the back, I've outlined various components. The signal comes in through this 6-pin connector. There's 6 pins here. It actually comes in on this side. But first, what the signal does is it goes through. You see this block here. That's an amplifying circuit, so that just amplifies the signal. Let's see if I can get a better focus on this. Okay. And then the amplified signal goes through an amplifier, basically another component of the amplifier, which is a peak detector circuit, which is on the side here. So that's in this block here. Oops. Okay. And finally, this larger block here that you see, this guy here is basically just for powering the SIP home. So that's a DC to DC booster. The circuit diagram is also available on our GitHub. Now that I have the resistors and capacitors populated, what I want to do is basically start doing the more important component, or the more advanced components that actually require direction, and I'll describe a bit how they actually fit in place. So let's start off with the diodes. So there's two Schottky diodes. Just grab two out. Okay, and diodes obviously have a direction. The direction is outlined on the silk screen. On the silk screen, so these are the diodes. Let's see if I can. Yeah, hopefully you can see. The diodes are these two components here, and the direction is indicated by the bar on the silk screen. Okay, my two diodes are in place. Okay. Okay, next up, why don't we do the L1? So L1 here, this is a 47 microhenry inductor. There's no direction on this guy actually. Okay. Well, let's do the op amp. So the op amp does the amplification part of the circuit and the peak detection part of the circuit. So this is an LT1807. It's a linear technology rail-to-rail op amp, and the direction is indicated on the silk screen by a little dot. So near pin 1, I always put a dot. And in this case, the pin 1 on the LT1807 is actually just the corner that has the 1 for the 1807 in it. Okay, and it has 8 legs. Let's tack those in place. And if you do run into problems trying to troubleshoot, where a potential issue is with your circuit, what I found with a lot of students is it's the legs on either the op amp here that are missoldered, they're missing, a connection, or it's the DC to DC booster IC. Same thing, just a missing connection. So what I like to do whenever I'm trying to troubleshoot a board is just quickly go over connection, or one connection at a time, make sure each one is secured in place properly. Okay, so there's my op amp. Next up, why don't we let's do the DC booster. So that's this guy here. And that's probably the most difficult component to actually populate. It's a bit smaller. It's an LT3461. Oops, and I don't want to take a used booster, just in case it doesn't work. I don't really want to have to troubleshoot this detector. Okay, so again, pin 1 is indicated on the silk screen by a dot. And in this case, pin 1 on the component is actually indicated by a little arrow that linear technology put on its component. Okay, and it has 6 legs. Okay. And I think that about covers, oh, hang on. So we also have on the SD card, there's also a 3.3 volt regulator right here. And the reason why we don't use the Arduino, so the Arduino actually has a 3.3 volt regulator on it, is that regulator doesn't supply enough current, so we actually have to put in our own. So I'll just put that in place. We actually use the current version of the detector. The one that you're working on might be slightly different, but the 3.3 regulator on the Arduino is actually used as a reference for the analog signal. Okay, so I think I have all the components populated on the back side here, all the small components anyways. We can finish off just by putting on the last two slightly larger components. Let me just grab something real quick. So we'll start off, why don't we do the OLED connection. So this is just a 4-pin header, okay, and it fits in place right here, okay. And always follow the silk screen. The silk screen really indicates exactly where it should line up. So that looks pretty good to me. And I'll just tack on the other legs. Okay. And you can see it's nice. I don't know if you can see that, but it's kind of difficult to see, but it's nice and flush against the board, which is what we want to see. Okay. Back up just a little bit. It's hard for me to see the camera too. Okay, and then let's put on the connection for the SD card. So your Arduino would have came with a 3x2 header that looks like this. We're not going to use it for the Arduino. Instead, we'll use it for the SD connection. So you can see, you know, we need 8 pins here. This is only supplying 6, but we'll start off with the 6. Just put. And the way that it fits in is the long legs fit up on the backside, and the short legs just go slightly through. Okay. So there's 6 of the 8. The other 2, we don't actually use all the connections on the Arduino. We come pretty close, but we don't use all of them. So I'm going to steal 2 of the pins off it. So this also came with the Arduino, and I'm just going to steal 2 of these legs. And the 2 that you're interested in is when you look at my silk screen, you know, the Arduino fits on these 2 rails here, and you can see these little dots beside each of the pins. Can you see those dots? Those dots indicate the pins that we actually use. So you can see, for example, up here, these 2 here, these pins don't have dots. We don't use these 2 pins. So I'm going to take these 2 and insert them over here. Okay, there we go. So this side is completely done now. Now we're just going to, or actually, sorry, I'm missing one more component. The SD card socket. So this is the most generic SD card socket I could find. I found it on Amazon, and they're about 50 cents a piece. Oh, they were generic. It looks like this is the wrong one. Give me 2 seconds. I think I have another one sitting over here. So it looks like I ordered the wrong SD card. Don't worry, I have extra ones up here. So it fits on basically like this. So this guy here I just purchased on Amazon. It looks like these ones here, you can see I somehow got the wrong ones. They're slightly different. I don't know if you can see that. I don't know what to do with these ones. I'll have to go and order some new ones of these. But this component here basically just fit onto this here, and I'll just swap these out as we get going. All right, so let's flip the board over and do the other side. So this side's a bit easier. So let's start off with this component here. So on the SD card, there's this, I think it's 16-pin IC, and it's used basically just as a logic level converter to communicate with the SD card. So again, there's a little dot indicating pin 1. And that's going to be pin 1 for this thing here. Okay, just like that. And I won't waste your time and put on all of them. I'll just tack them in place and sneakily swap it out with one that's already done. Okay, so that's what it looks like. Okay, and then we'll do all the other big components here. So let's start off, we'll do the Arduino. Arduino should always be done last. And actually, to be honest, the Arduino, you should upload the code first and make sure it works and you know how to work it before soldering it in place. You can imagine that if you put it in and you get a problem, it should actually fit this way. Trying to remove this is nearly impossible. Okay, so let's start off with the BNC. BNC connector fits like that. And you want it to be nice and flush against the board. Yeah. And we can solder the other legs in place too. Okay. Next up, why don't we do the reset button? So the reset button has tools, and it just basically plugs directly in through these holes. It snaps into place. There we go. Okay. And we solder on from the bottom. Okay. Next up, let's do the 3.5 millimeter connection. So this is actually a 4-conductor connection. We only actually use 3 of the conductors. So you know your audio cable, it may have 3 or 4 connections to it. Currently, we only use 3 of them. Okay, so it looks like he's in place. How about we do the temperature sensor? So the temperature sensor, you can see the rounded design on the silk screen. That's to indicate the direction on your temperature sensor. So here's my, I think these are TMP36 temperature sensors, analog temperature sensors. Okay, and so it just plugs in. And this is just to measure the local temperature. Plugs in like that. Okay, and put some solder in. Okay. Next up, so the thing that actually plugs the SIPM in is this 6-pin connector here. It's a 2x3 header connection. Okay. And we'll just solder it in again from the back side. That doesn't seem to help. Okay, and you can see this is a 6-pin connection. We actually use three connections here. They're all redundant. So if we look here, if we look at the silk screen, I don't know if we can focus and see what it actually says here. But the top 2 here are the voltage that goes to supplying the SIPM. The middle 2 are ground, and the bottom 2 are the signal. So we send out 29.5 volts through the top 2 to power the SIPM. Ground is middle, and then the bottom 2 is where the signal comes back in, and then it goes through the circuit here all the way to the Arduino. It looks like I think I have every connection except for the Arduino. So we'll put that one on right now. And then we can actually basically just fire this up and see if it works. So I put the long legs through, and the short legs sticking up through the top. And you want this, again, you want this to be nice and flush against the board. You can imagine that since everything fits snugly into a case, you need everything lined up properly. Okay, so they stick through like that, and then we just solder in from the bottom. And actually, this takes a second to do. So normally if you want to do like this quickly, is you do a couple of these at a time. Like if I need a bunch of detectors, I'll do 6 of these at a time, and it'll take a couple hours to do. Building one detector like I'm doing now probably takes an hour of time. But building 6 probably takes like 2 hours in total. So the biggest time commitment just comes from pulling out the resistors and capacitors and organizing your components. Okay, that's that side, and I'll just do the other side. Okay, so that looks pretty good. My headers are in place. They're ready for the Arduino. What I'm just going to do is step away from the camera and just clip off all these protruding pins. So just give me 2 seconds. Okay, headers, pins are all gone. So I think it's done. So I think I'm ready to attach the Arduino. So it looks like I'm missing Arduino and LED. So Arduino fits on, and you can see the USB sticks out the back. And I'll just tack this in place real quickly. Now we chose the Arduino Nano because you can actually buy this from Chinese realtors for, or sorry, not realtors, Chinese companies for about $2.50 off of eBay, which is actually cheaper than I'm able to actually build the Arduino myself. So that's the reasons why we stick with this rather than having students build their own microcontroller for this. I have ran into, I think I've probably purchased 200 Arduinos so far, and maybe about 3% of them have had problems. So it's good to upload code. I know the code was already uploaded to this guy, so I know this guy hopefully already works. I would have uploaded about a month ago. The final component that I'm missing here is the LED. And the LED fits on with the direction indicated by the silk screen. Okay, and you basically want the LED just barely sticking into the board. And long leg should go to the right when you're looking at it directly at it like I am. There we go. So we have a complete PCB here. So this guy is, well, actually not quite complete. I forgot to mount the SD card reader. So here's the SD card reader, and it fits onto our 8-pin connector here. Just like that. Just make sure it's nice and level. You can see it's kind of level. Tack one pin in place. Make sure we like the position. I think that looks pretty good. And do the other 8 connections. And actually here I'll even cut off the extra pins on this guy as well. Okay, and I'm just going to cut these pins off, so 2 seconds. Okay, there we go. So we now have a complete main PCB. Okay, and the way that we're going to test this is I'm going to, so the first thing that we're interested in is to make sure that we're actually providing the right power to the SIPM. So I'm just going to grab the multimeter. And a little power cable here. And I'll just put some power to this. Okay, lights up. And all that I want to check is I want to go look between the high voltage, the HV pin, and the ground pin, the middle one, and see that it's positive 29.5 plus or minus 0.1. Let's see if I can let you guys see this too. You can sort of read that here. Let's say 29.4. Okay, so I'm confident in the DC to DC boost converter. So that means, you know, there still could be problems with the circuit, but the boost converter component, this guy here, I know was all populated properly and I got the correct voltage out, so I'm not going to damage my SIPM when I plug them in. The other potential problems could come from the other parts of the circuit, like the amplifier or the peak detector. Sorry, amplifier or peak detector. And in the fourth video, I'll show you how to troubleshoot those. So this is it. So this guy's done. You can plug in your screen if you want. We can test that too. I'll plug in a screen into the 4-pin LED and basically just fire it up, and hopefully the splash screen for the detector pops up, unless the screen's broken. Oh, okay. There we go. Looks good. And yeah, you can see it just says nonsense now because we don't actually have anything plugged in here. Okay. So this guy's done. So it looks like the main PCB worked. The next video is going to go in how to build the SIPM PCB. That one's a bit shorter. And then the final video we'll have a working detector. There's probably like a 10% chance that I mess something up, but in the fourth video, if I mess something up, then we can just troubleshoot it, and it'll take an extra 5 minutes and you'll learn something. But yeah, so I'll see you in the next video.